Thanks for checking out our channel here. This is going to be a test and repair video, possibly on one or both of these units. These are Gallagher B150 and B160. They are the same exact model internally. There's probably been some updates on this one board-wise versus what this one is, because this one's probably 10 years older than this one. But these are both good old school units. The B150 was around from the early 90s up until it changed over to the B160 about I don't know, 1998, 97, I don't know, somewhere in that range. And then it was around to about 2004. They did make an E12 with a little 2 next to the 12. That was made in the late 80s. That's basically the same thing as this one. So this is about a 35-year-old design, even though this unit here is a 2002 model. Based on when it was built, so it's 22 years old. But the technology goes back about 15 years before this one was built. And this one, serial number wise, is that number, which is just a sequential number, has no date code format. The Gallagher went to a date code format back in like 98, 99. They use the same date code format today. So the note on this one says good. The note on this one says flood. So this one may not be repairable, but we'll see. Don't know. We're going to open up this orange one here first. I want to show you what, this is what they look like inside, so you kind of get an idea. This one's definitely early 90s. I worked on another B150 from the same customer that had the red capacitor. This was the old black one they used. It's probably fine, but we will probably check it. Let's go and take the cover off this one. Now, when it gets flooded, it got submerged. How bad is it? There's some dirt caked up inside there. Right at the bottom, see, the unit mounts on the wall like this, and so the water settled down right in the bottom and boogered up that switch pretty good, I imagine. Cannot get new boards for this model. Let's pull this board out. Oh shit. And the solder joints on this little inverter, converter, step-up transformer, what the hell it is, are definitely loose, so we need to fix that. See if the switch actually moves. Oh shit. Nope. Pretty rusted tight, so I don't know if we're gonna be able to save the switch. It might be stuck in half power. Get some love juice down inside there. See if we can get that switch to move. Oh, there it goes. Ah, there it goes. Starting to move again. Oh, bound up again. Let's push that position. Let's put a little more juice in there. Give it a few smacks, kind of jar some stuff up. Come on. Yeah, so it still keeps getting bound up. So what we may tell the customer to do is leave it on, don't turn it off. Just unhook the battery from it. I may end up like removing the switch piece, blocking it off so they can't accidentally turn it off, because it may get to a point where it gets locked up again, and if he can't turn it off, I can't turn it on or whatever. Let's get this inverter or whatever the hell it is, solder back on. It's holding on by a thread. Solder. I don't know if we're going to be able to fix this one or not, but what the hell, let's try it anyway. Yes. Let's clean some terminals up, see how rusted those are. That's not good for connectivity, but it cleans right up real nice. It's just on the surface. Bend that tab over like that so we get to the back side. Whoops. There goes the capacitor. We'll check that as well. Probably put a new switch in there, or not a new switch, because I don't have a new switch for this type. Let's get a can of air out. We may end up having to replace these connectors here. I think I've got some of those, or at least some that might work. I don't know. Let's move the switch to the on. Whoops, wrong unit. Oh, you check that capacitor too. It's pretty rusty too, but it doesn't look as bad as the switch does. Check this capacitor. It's 20 microfarads. Go across it. 19.6. Come on. Snaps in there. Come on. Take a screwdriver back behind there. Do that. It's behind that little lip. Let's hope that this unit goes to working. That's why. In there, right. Okay, almost. Come on. Okay. Hopefully the sparks and the fire don't start. I have it left over. It stinks. Let's put power to it. My power supply turned off, so let's turn it on. Okay, nothing so far. It's not even putting a draw on my power supply. Let's turn it off. And of course, the switch didn't. The physical switch. Oh, that's a problem. That's one reason why. The board's not in there all the way. Come on. Now it's in all the way. Alright, still no draw on my power supply, but no amp draw, so it's not. Let's see if we're getting power to the board though. Okay, hold on. Turn this off. I think when the switch is on, the power at this power here, it goes. The power disappears from there. So let's turn it back on. Test power again. Nope, we are not getting 12 volts to the board. So either one of our clamps has gone bad, which this red one looks pretty suspect. Let's just hardwire, which I'm just going to take my clips off my power supply and I'm going to apply it right to the board. Let's turn the power supply off. Let's turn the switch on. That's starting to move better. Starting to. Still nothing. Let's check that fuse. Well, fuse is good. Toes. I don't waste too much time on this. This one might be a lost cause. Diode's good. I imagine the problem might be the switch, but I can't. I've looked for switches like this. I can find them where they're vertically mounted, but this one's like angled, it's mounted like this. All the solder joints are going down, but the switch is going out to the right, like a right angle. So most switches you find like this one are mounted this way. The solder's down or whatever into the board, and the switch is faced up. I cannot find a right angle one. And I don't know. It's not really. There's so much going on with that board back there, trace wise. It's hard to figure out where the hell everything's going on there. I don't want to waste a bunch of time on this one. Let's move over to the other one. This one might be a lost cause. There was no charge for looking at it. And it's 20-some years old, got flooded, so that's the reason why it went bad. Instead of stripping this cord back, we got to take that insulation off there because it's been cut. Let's just apply power right to the board. Looks like the red goes here, 12 volt positive. Black goes there for 12 volt negative. The switch is turned on. Let's put our turn the power supply on. Wait a minute. What's going on here? I'm a power supply. Power supply is turned on, but why aren't I getting any? Let's try these leads. Okay, let's go. Okay, we'll go back to that other one here in a minute. Let's put our power back on. I think something's wrong. I got two sets of leads on there, and I think something's wrong with that. Let's turn this off. Okay. Let's bring this one back over again. Get this board installed back in there. Let's put power back at the clamps. Look at that. That old one that's flooded does indeed work. Look at that. Look at that. I think that's something. My leads there's a problem with one of my wires. I'm like, power supply. Been on there probably 10 years, 8, 9, 10 years, whatever it's been. I've been using this particular power supply. Let's check the, the capacitor is good. Let's check peak voltage out of it. With no load. Not quite right, because I'm only getting 5,000 volts. Oh, that's why. The switch board is on half power. Now it's on full power. Now it sounds healthier too. There we go, 7,000. Right where it's supposed to be. Full power or 500 ohm load. It should be about 1 joule. 0.9, 0.91. Right where it's supposed to be. Woohoo! So this one is good. I'm going to, that one's probably okay too, the other one. Let's fix this switch where they can't jack with it. Let's pull this board out. We'll leave the switch on the board in the on position, and then we're on full power, and then we're going to take this plastic switch piece out and get rid of it. Pinch that through, and that thing pulls right out. And then you have this little white lever thing that kind of, as you turn that lever there, this little white piece there will grab the board. But the bad thing is now there's a hole right there. where bugs can get in there. Well, how do you fix that? You plug the hole with some gunk to keep the thing from. This is a flex glue, so I like this stuff. Just plug it because it's not runny, and comes in like a toothpaste tube. And we've used quite a bit of this stuff over the years. Just roll a little bit out, put the lid back on. Set it back to the side. It takes about 24 hours for that to cure, but it turns to like a rock. And you have to worry about bugs getting in there and making their home. So now let's put this board back up inside there. Oh, woo! Lucky dog. Peel the flood sticker off there so we know that's nothing actually wrong there, or not. It's not flooded no more. Charge them a little labor, call it done. And then, well, might end up. We'll look at that clamp again. Might end up putting a new clamp on there. It's pretty janky inside. Plus, it's kind of off kilter. That plastic thing, I think, it's about to break. This one feels nice. This one feels really good. The black one does, but the red one, a little weak feeling. I don't know if we checked the capacitor in this one or not. Check it real quick though. 20 microfarad capacitor. We just across it. No polarity. 19.7. Sounds good to go too. All right. Well, fixed the board on that. Cleaned it up, everything that we could, and put a new clamp on there to be good. This one's a little labor on this one. Call it one good too. So, all right. Well, thanks for checking out our channel. This is kind of a fun little ordeal to go through. Till next time, see you guys later on.